Let's have an example of a white noise given to a low-pass filter. Suppose that we have a white sensitization random process, which is white and it's stationary. So here, this random process x of t is applied to this LTI system with h of t equal to e to the power minus ct ut. This is obviously similar to an RC circuit, and we get y of t as the output, and obviously our xx of t1 and t2 is equal to q delta of 2 is t1 minus t2 is the time delay. So if I convolve these with ht2 conjugate, I convert these to ry, and then I know that ry of t1 and t2 is equal to rxy of t1 and t2 convolved with h of t1. So I do the first convolution. If I do this convolution, this will become q times h conjugate of, I substitute this one here, which is going to become h of t2 minus t1. Okay, now if I convolve this one with h of t1, I get the second one. So before going there, this h of t2 minus t1, I put it here. So I replace this time t and this, both of them by t2 minus t1. So I put this one, I substitute it by t. I substitute t by this one. And I get this expression. Now, so if I convolve these with ht1, remember that this is also e to the power minus c t1 and then ut1, and then you apply. And then here you could apply the convolution integral or whatever you want in order to get the results. You simplify this one, and then you can multiply these ones and then try to get the integral, and you get this one. So if you look at this function, you will see that you have two terms here. This is and this term as t1 and t2, if both of them they increase, this will tend to become equal to 1. So this is the transient part, and this is the stationary part. So the autocorrelation function, the stationary part, is only a function of t1 minus t2. So you see that the random process y is asymptotically white sensitization because it is applied to your random process at time t1. So initially it is not stationary, but when minimum of t1, t2 is large enough, these terms becomes 0, and then the autocorrelation function of t1 minus t2 will become only a function of t1 minus t2 or t2 minus t1.